For millennia, we looked up at the night sky and saw a universe of serene, unchanging permanence. The stars, arranged in their familiar constellations, seemed like diamonds fixed upon a velvet sphere, eternal, silent, and still. This perception, a foundation of human thought for ages, is a profound illusion. We are now on the cusp of a revelation, a new era of cosmic understanding where the illusion of stillness will be shattered forever. We are about to witness the universe for what it truly is, not a static collection of objects, but a dynamic, violent, and ceaselessly evolving story. We are about to watch the cosmos in motion. At the heart of this revolution is a new eye on the universe, perched atop Cerro Pachin in the Chilean Andes, the Vera C. Rubin Observatory. This is not just another telescope. It is a monument to a new kind of astronomy. Its primary mirror, a colossal 8.4 meters in diameter, is engineered to gather vast amounts of light from the faintest, most distant corners of the cosmos. But its true power lies in its partnership with the largest digital camera ever constructed for astronomy. With a staggering 3,200 megapixels, this camera possesses a field of view so wide it can capture an area of the sky 40 times the size of the full moon in a single exposure. Every few nights, for 10 years, the Rubin Observatory will scan the entire visible southern sky. It will take an image, move to the next patch of sky, and repeat, creating an unprecedented celestial survey. But this isn't about creating a static map. After capturing an image, sophisticated software will instantly compare it to previous observations of that same region. Within 60 seconds of an image being taken, any change, a new point of light appearing, an old one fading, or an object moving will be identified. An alert containing the object's position, brightness, and rate of change will be broadcast to a global network of astronomers. This is the Legacy Survey of Space and Time, or LSST. It will generate a torrent of data, roughly 20 terabytes every single night, culminating in a data archive of hundreds of petabytes. It's an amount of information so vast that it defies easy comparison, a digital deluge transforming our relationship with the cosmos. To grasp the magnitude of this shift, we must look back at our history of charting the heavens. The earliest astronomers, like Ptolemy in the 2nd century, created star catalogs that defined the celestial sphere as a fixed, divine map. For over 1,000 years, this view held sway. Later in the 18th and 19th centuries, astronomers like Charles Messier and William Herschel compiled catalogs of nebulae and star clusters, but these were still snapshots, a celestial atlas of static objects. Even the transformative Hubble Space Telescope, which has given us our most profound images of the universe, operates by taking long, targeted exposures of specific objects. It produces breathtaking portraits, but they remain portraits nonetheless. The Rubin Observatory changes the entire paradigm. It is not creating an atlas, it is directing a movie. For the first time, we will have a continuous, high-fidelity record of the cosmic drama as it unfolds across the whole sky. We are moving from a static picture to a living narrative. This shift from a static to a dynamic view of the cosmos forces us to confront a deeper philosophical truth. Our perception of reality has long been based on the idea of things, solid, stable objects that define our world. But modern physics and philosophy suggest that reality is more accurately described as a sequence of processes. Think of a waterfall. A photograph captures a static image, a thing we call the waterfall. But a video reveals the truth. The waterfall is not a thing at all, but a constant process of water flowing, changing from moment to moment. The ancient Greek philosopher Heraclitus understood this profound insight when he declared, "One cannot step in the same river twice." The river is defined by its flow, its constant becoming. The Rubin Observatory is applying this principle to the entire universe. It will show us that stars, galaxies, and even the fabric of spacetime are not fixed entities, but are part of an unceasing flow of cosmic events. We are learning to see the universe not as it is, but as it is becoming. The scientific power unlocked by this continuous celestial movie is immense. Consider the threat of dangerous asteroids. Previous surveys have been excellent at finding the largest, dinosaur-killing-sized rocks, but have struggled to track the smaller, city-threatening ones. Rubin's rapid revisit schedule, imaging the same patch of sky repeatedly, will allow for the incredibly precise calculation of orbits for millions of asteroids. By tracking their subtle movements over time, we can project their paths decades, even centuries, into the future. This will transform our planetary defense from a reactive scramble to a proactive long-term strategy, giving us years or decades of warning to develop and deploy mitigation methods. If a potentially hazardous asteroid is found on a collision course with Earth, then there is the spectacle of stellar death. When massive stars exhaust their fuel, they collapse and explode in brilliant events called supernovae. Rubin will discover thousands of these every year. It will catch them at the very moment they ignite, providing crucial data on their initial rise in brightness. This will allow us to distinguish between different types of explosions, like a Type Ia supernova, the detonation of a white dwarf star, which are used as standard candles to measure cosmic distances, and a core collapse supernova, the death of a single massive star. By observing the very first light from these cataclysms, we can test and refine our fundamental models of stellar evolution. Understanding the life cycles of stars with a clarity we could only dream of before. Perhaps most profoundly, Rubin will peer into the invisible universe. We know that about 85% of the matter in the cosmos is dark matter, an enigmatic substance that does not emit or reflect light. We can only infer its presence by its gravitational pull on the things we can see. This pull can bend the path of light from distant galaxies in a process called gravitational lensing. When a massive object, like a clump of dark matter, passes in front of a distant star, it can briefly magnify its light, creating a transient brightening event. Rubin is projected to observe thousands of these microlensing events. By analyzing the pattern and frequency of these flickers across the sky, astronomers can create a detailed map of the distribution of dark matter, revealing the invisible scaffolding upon which our visible universe is built. And beyond the known, Rubin is a machine built for discovery. The universe is filled with rare, fleeting phenomena that have, until now, largely escaped our notice. Think of kilonovae, the explosive aftermath of two neutron stars colliding. These events, which last for only a few days, forge most of the heavy elements in the universe, like gold and platinum, and also unleash gravitational waves that ripple through space-time. Or consider fast radio bursts, millisecond-long blasts of radio waves from deep space whose origins remain a complete mystery. Because Rubin is always watching, it is uniquely positioned to catch these ephemeral events in the act. Each alert could signal the discovery of a completely new type of cosmic object or physical process, opening up entirely new fields of astrophysical inquiry. This impending flood of data forces us to confront our own history of observational bias. Our belief in a static universe wasn't a philosophical choice, it was an artifact of our limited tools. We saw stillness because our eyes, and later our telescopes, could only capture fleeting moments. We mistook the snapshot for the entire story. The universe was always in motion. We were simply unable to see it. This realization connects astronomy to the most fundamental principles in other fields of science. In quantum mechanics, the vacuum of space is not empty but seized with the constant creation and annihilation of virtual particles. In biology, life is not a fixed hierarchy but the result of billions of years of continuous evolution and change. The dynamic cosmos reflects a universal truth. Everything is a process. Humanity's role in this story is also evolving. We are no longer just passive gazers, cataloging a fixed creation. We are becoming active, continuous witnesses to cosmic processes, partners in a real-time dialogue with the universe. We stand at a precipice, looking out at a cosmos about to be revealed in its true, dynamic glory. The data that will flow from the Rubin Observatory will not just fill textbooks, it will reshape our fundamental perception of reality. We will see the universe not as a collection of things that exist, but as a grand, interconnected process of becoming. The story of the universe is still being written, and for the first time, we are about to read it, page by page, as it happens. Thanks for watching. Follow for the next chapter in our cosmic journey.